Alright guys, we have a linear geometry problem here. So this linear equation tells us we have 3x negative parentheses x negative 7 close parentheses is equal to 4x negative 5. This is very important. It's telling us everything over here is equal to everything over here. So that equal sign says it's balanced, okay? So whatever we do in terms of adjusting the amounts or values of the data on one side, we have to do the same thing to the other side in order to keep this equal sign a true statement, okay? So that's only in terms of adjusting the values. Now if you want to work this problem out for yourself, go ahead and pause now, write down the problem and sort through it. If not, we're going to keep plugging away if you want to follow along. So according to order of operations, PEMDAS, what's the first thing that we need to do is parentheses, right? And we have this negative sign right here outside the parentheses. When we see a negative parentheses that says negative multiplied by everything in parentheses, we assume at least a negative 1, right? If there's no other number written there. 1 is the multiplicative identity, so we don't need to write it. In other words, whatever we multiply by 1 maintains its identity. In other words, if it's a 7, it's still a 7. If it's an x, it's still an x. The negative, however, adjusts or changes the operation in front of it. For instance, we have a negative times a positive x here as we distribute, right? So that's going to become a negative x. A negative 1 times a negative 7 is going to make that a positive 7. Because a negative times a negative is a positive, right? And a negative times a positive becomes a negative, right? So we have negative x, positive 7. We go ahead and bring that down, right? We've gotten rid of the parentheses, right? And we've used up this negative 1. So now we're left with, on this side of the equal sign, we have 3x negative x, positive 7 equals 4x negative 5, right? So everything's still true because all we did was combine things, combine like terms, or perform operations on one side of the equal sign. We didn't change its value. We didn't add or take away any sort of value to it. But we're going to, well, actually we're going to first combine these like terms. We have 3x minus x. What's that? We're going to be down to 2x, positive 7, right? And here's that positive 7, right? Is equal to 4x minus 5. So I kind of got the cart ahead of the horse a little bit there, but we are now going to start adjusting some things so we can isolate the variable term on one side of the equal sign over here and the constant terms on this side of the equal sign, all right? So first things first, let's go ahead and take away 7 here to bring that to 0. Whatever we do to this side of the equal sign, we have to do to this side of the equal sign. So we got to take 7 away over here, okay? Now, let's take away 4x on this side, because that's a positive 4x, so we're going to minus 4x, and that will cancel that out. Whatever we do over here, we now have to do over here. So we minus 4x. Okay, so now we can rewrite that so it looks a little cleaner. Alright, so we end up with 2x negative 4x is equal to negative 5 negative 7. And this should still be a true statement. This equal sign should still be true because what we did to one side, we did to the other side, right? So we kept it balanced the whole time. If we took something away here, we took the same amount away here. If we added something here, we added the same amount over here, right? So that equal sign says it's still balanced. So now we have 2x minus 4x, or 2x negative 4x. Okay, so we're simply going to the number line and saying 2, 1, 0, negative 1, negative 2, negative 3. And this is what we're visualizing, right? Just so you can understand what we're doing here, right? We start at 2. This tells us what direction on the number line we're moving, and this tells us how many places, right? So we're going to move this direction, right? 4 places. So starting at 2, 1, 2, 3, 4. So we end up with negative 2x is equal to negative 5, negative 7, right? Now we look over at this side of the equal sign. And we say, is there anything over here we can combine? We can. We have negative 5 minus 7. So we're at negative 5 on the number line. Negative 6, negative 7, so on and so forth, right? So we're starting at negative 5 right here. We're moving in the negative direction, this direction, and we're doing it 7 places. So we would go 1, 2, so on and so forth, right? And we'd end up with negative 12. So we have negative 2x, we bring that down right here, Bring down our equal sign, equals negative 12, right? Which came from this. So we have negative 2x equals negative 12. And if you're wondering, well, I thought you said whatever we do to one side of the equal sign, we do to the other side of the equal sign. In this case, we were combining like terms that were already there. Those values were already on that side of the equal sign, and the values in terms of the left side of the equal sign, those were already there. So we haven't taken away or added to in those situations, so we didn't need to do to one side what we did to the other. We were just doing what's called combining the like terms. The terms that could be combined mathematically, that's what we were doing. So now we have negative 2x equals negative 12. So we're trying to figure out what x is. That's the goal all the time, right? We're trying to solve for that unknown. So what we're going to do is we're going to break this apart. This says negative 2 times x. In order to break that apart, we have to divide away negative 2. And what that does is that allows us to cross cancel, right? And if you're confused how or why we can do that, let's look over here. So we have negative 2 times x, right, divided by 2, okay? So that's the same as, we could say, like so, couldn't we? Right? And so we're, whoops, that was a negative 2. So we're able to cross cancel because negative 2 over negative 2 is equal to, right, because it's a negative divided by a negative, and it's 2 over 2, so it's 1. But whatever we did to this side in this case, because we were dividing away negative 2, we got to divide away negative 2 over here. So divided by negative 2. So we end up with x is equal to negative 12 over negative 2. Of course, this can be carried out, right, which we'll do right now. So we have negative 2 divided by, or excuse me, negative 12 divided by negative 2 is equal to x. So what does that come out to? A negative divided by a negative is going to be a positive. It's going to be positive 6 is equal to x. So x equals 6.